First of all, welcome all the warriors, welcome all the JEE enthusiasts, welcome aboard to the Pathfinder series, which is for the 12th standard students. And today we are going to study all the properties of magnetism. We are also going to see the different characteristics. In our previous lecture, we have studied bar magnets, the field, the potential due to it, and also the Earth's magnetism. Today, you're going to see the different characteristics, and then you're also going to classify different materials based on the properties they exhibit in magnetism. You're also going to see that at the end of the day, a magnet is nothing but a collection of teeny mini magnets at atomic level, and every atom is nothing but a small magnet. And all this with me, Shreyas, your physics master teacher at Vedantu. I hope you can see me. I hope you can hear me now. Welcome aboard. Welcome aboard. Welcome aboard. Nice to see all of you. Hi Panchami, Janesh. Hi Akash. Hi Joker, Ankit. Hello MBG, Zayad, Mahak. Hello Harshita. Hello Pitugu. Hello PR, Vikram, Prakash, Bala, Vishal. My God, so many new students. And those of you who are very new, probably for the live session, because I can see a lot of new names. Come on, let us know and make new friends, because all the students out here are, very enthusiastic to crack the JEE 2022 examination. And these are your friends whom you are going to interact and whom you are going to stay with for the next 1 year. And I feel that you should bond really well on this channel. This is just a source. This is like a medium for you guys to probably interact. And guys, I am Shreyas. I am the physics master teacher, also the HOD of the JEE Physics division. And I have been teaching for a long time, over a decade. And my intention is just to make sure that you guys love physics, you guys enjoy physics, and make sure that this love translates into marks eventually, and you guys clear the examination and get into a very good college. If you want to know more about me, you can follow me on my Instagram handle. And also, let me tell you, this is the schedule for this week. Hello PL, yes, let's get set, go. Thank you Susmita for loving my teaching. Hi Jamesh, I'm very good. Harshita, nice to see you from Andhra Pradesh. I have a lot of relatives and a lot of friends in Andhra Pradesh. Thank you Bhargav for all the love. Hi PR, thank you. Welcome aboard. I'm very good, Sachinandanda. All right. So Joker, yeah, you have been watching my sessions recorded. So good to see you live out here. I'm pretty sure you'll have a very different experience out here. So Panchami, mechanical properties, well, probably it will take some time, okay, because it's a 11th standard topic. Hi Prakash, I'm very good. So wait for it, Panchami. All right, don't worry. Aishwarya, good evening. A lot of Karthik and everybody else also saying that they are from Andhra Pradesh. I'm very good. Yes, let's rock it. And in case you missed this session of bar magnets, please watch it. It's there in the replay. Remember, tomorrow you're going to have Menti quiz at 7:30. I hope you guys are geared up. Prepare very well. Not just these two chapters, guys. You're going to have the previous chapters as well. Magnetisms, Ampere's law. You're going to have Biot-Savart's law, solenoid, toroid, wires, force on a wire, Lorentz force. All these concepts together. All of this over here, guys. Yeah, so I hope you guys are going to be prepared. Make sure that you are live in this session and join using the Menti quiz code so that you can participate in this amazing quiz. And there are more than 15 questions in this quiz. So you're going to have ample opportunity to actually prove your worth in this quiz. Okay, so let's get started. First things first, okay. Let's talk about what happens when you take a material and place it in some external field. So anything, let's say I take a rock and place it under the influence of somebody else's field. Maybe a metal, place it in somebody else's magnetic field. We have already studied what happens when you take a material and place it in somebody else's electric field. Do you remember that from electrostatics? Just a quick recap. Remember, in electrostatics, if the device or that object was a conductor, then what happens? The charges are induced in such a way that the field inside the conductor will become zero. How many of you remember this? If you remember it, put up a 0 in the chat box. Remember, when you take a conductor and place it in external field, the charges will induce in such a way that the field inside the thickness of the conductor becomes 0. If you remember this, put up a 0 out here. Well, Darshini, all the new members, do not forget to first of all smash the like button and hit the subscribe button. If you are new and if you have forgotten that maybe you have subscribed but you have not hit the like button, that's the fees for attending today's class. Smash that like button down there, and if you are new, please hit the subscribe button. Okay, so very good. A lot of you saying zeros. Excellent. Now, here is the next thing. If it was an insulator, then it is not going to be 0. Charges are induced, but they are not so mobile. Field is there. In fact, it is not 0. And we have seen that there is a dielectric constant of the material which is going to give me the field inside that material. In fact, the field reduces k times. Remember this? So if the external field was E naught, the field inside will become E naught by k, where k was the dielectric constant, guys. I hope you now remember that. Yes, polarization occurs. Correct, PL. Very good. Navya, welcome. Don't worry, even if it's your first time. I'm pretty sure this will not be your last time. After this, you will become a regular student, Navya. Okay, unknown Krish. Okay. So, Rajani, which chapter are you going to start for 11th standard? I am going to start relative motion. Bacha, I have already posted in the community. I have also posted in the Telegram. I have posted it. I have told this many times. So, please understand, I have to take care of many batches. So, yes, 11th standard nurture series starting from Monday. Don't worry. I love you guys. Don't worry. I am not running away. Okay. Now, what happens in case of magnetic field? Let's see. First of all, let's say you have a material and you apply some external, let's say you have a material and you place some external magnetic field. Okay, you have some material and you place some external magnetic field like this. What happens is the field which is induced could be in any way. It could assist it or it could oppose it. So if the induced field opposes it, then the field inside the material will be more or less. Come on guys, answer in the chat box. Correcto. It will not become more because external field is here, induced field is opposite. So the net field inside will be less and it will be B naught minus B induced. So the net field, the net magnetic field will be B naught minus B induced, and you can see it has reduced. It has reduced. That's what will happen. This is scenario number 1. Scenario number 2 is that you have a material, you apply external field, but the induced field assists it. In that situation, you will see the net field inside will be obviously more, and hence in those scenarios, B net will be B naught plus B induced. That's what will happen. Now, why will it oppose or why will it help? That depends on the magnetic material. We are going to study it in the second half of today's session. Don't worry or break your head over it. Yes, Nandini, this will be also enough for NEET. In fact, it is more than enough for NEET. Okay, because this is JEE studies, so JEE has little bit more depth in whatever you're going to study. Now, in general, B net will be vector wise B external plus the induced. So this is external field and this is nothing but what is induced. Now this induced could be parallel or anti-parallel to the external field. It depends. What does it depend on? It depends on the material. Remember that. It depends completely on the material. Yeah, that's what happens. Everybody clear till here? Shall we go ahead? Yes, Ankit, correcto. Rishikesh, this is a topic which is only there in JEE mains. This is not there in JEE advanced. And whatever we do otherwise, let's say for example EMI or electrostatics, we have done it from both mains and advanced point of view. Remember, this is a JEE channel. Obviously, when I say JEE channel, it does not mean JEE mains. It means JEE mains and advanced. So when I say I am studying, making you study for JEE, don't ask me, sir, is this for JEE mains or JEE advanced? Obviously, it is both. Okay, I hope it makes sense. Thank you, Abhinav and others, for wishing me, Badri and all of them, wishing me happy Gauri Purnima. Thank you guys. So if this much is clear, let's go ahead. So all the pointers, whatever I talk about, will be there as PDF in the notes which you can download, and the notes are available after a day in the description box below. Okay, that's how it is. Okay. Now, before I talk about the different properties, let me tell you guys, if you are interested in joining the courses which I am conducting, the micro courses which I have taken, and you want to see HC Verma solutions, you want to see irregular questions, you want to solve previous year questions, you want to solve numericals and apply those concepts, you are facing difficulties, etc. You want some derivations or any other teachers micro courses, long-term batches, you want to prepare for KVPY, you want the booklet of Tattva module which has all the conceptual problems, you want doubts to be solved, you want test series, then let me tell you that there is a link in the description box through which you can get all of this. More than that, we promise you VIP, which is Vedantu Improvement Promise, saying if you do not perform, if your performance does not increase, then whatever amount you paid is returned back. No questions asked. Obviously, you have to attend the classes. You cannot say I did not attend and I did not improve. That doesn't make sense. And the reason why we are confident is because of the ranks and the results we produced. Look at this, the JEE Advanced results of Vedantu students is 6 to 7 times higher than the students who do not attend Vedantu classes or take coaching elsewhere. In CBSE 12th, it is 5 times at least higher than the students who do not take coaching from Vedantu. All of these courses are available at very affordable prices, 3060 rupees per month. Okay, there are many packages which you can take. So if you want extra doubts and personal mentor, you go for classic and the plus version. And the batches start every Monday. And if you want to know more about it, there is a link. Join that link or ping me on my Instagram handle. Definitely, I will answer all your queries. Okay, so you can use my coupon code to get additional discount of 10%. Okay, so that's about Pro. I'll talk about more in detail maybe towards the end. Now, Chaitanya have already covered dip angle, ferromagnetic properties I'll be doing today. Yeah. So let's get going. Portions for JEE mains or JEE in general is obviously not over, but for the 2021 batch, yes, it is over. We have started Pathfinder series and all of that. Okay. Now let's define the different terms like magnetic intensity or magnetizing field. This is the first term which you are going to see. First term which you are going to see. Now, these questions are directly asked, and if you have even attended any of our previous discussion sessions of JEE Mains, you will see there have been questions for sure on this chapter. So you cannot tend to ignore because the formulas are very simple, concepts are very simple, and calculations are very simple. You cannot ignore this. This is like 4 marks in your pocket. Do not ignore. Magnetic intensity or magnetizing field. What is the meaning of that? This means, the degree till which okay, so this is basically the degree to which an external field magnetizes a material. So, for example, let's say I have a solenoid and I place something inside. The solenoid has some current flowing through it. The solenoid's current will produce magnetic field around it. If I place something inside, I don't know, I could place anything, wood, stone, marble, anything. That will be magnetized by the solenoid's magnetic field. So the solenoid has some magnetizing field H. That magnetizing field H or magnetic intensity H is defined by that external field by mu naught. So this is your external field. Keep this in mind. This is external field. In the case of solenoid, let me take an example. For solenoid, what would be the value of H? H will be B naught by mu naught. Recollect what was the formula for magnetic field by a solenoid? Wasn't it mu naught Ni? Try and remember this. Mu naught Ni was the formula, guys. So divided by mu naught goes. So shouldn't it be Ni? So the H value, magnetizing field value for a solenoid is Ni. More the turns, more the current, more the magnetizing field. As simple as that. Thank you, Parthiv, for all the love. Alright, that's it. Great. Bhaskaran, come on, join in. If you have missed, please rewind the class and watch it at 2x speed. You can still catch up. What is I? I is the current. So what is I? This I is nothing but the current. This is from the previous chapter. If you have missed the previous chapters, watch the lectures. I have covered solenoids in detail. What's the field due to solenoid, toroid, wire, curved wires and coils and all of that. This is turns per unit length. I have told you about this before. Quickly guess and tell me what should be the unit of H. What should be the unit of H? In fact, if you look over here only, you will get it. What's the unit of H, guys? Come on, figure this out. N is turns per length, I is current, turns does not have any unit, current is measured in amperes, length is measured in meters. So what should be the unit? It should be ampere per meter. That should be the unit. Check this out. Yes, very good. Some of you have figured it out. Excellent. Now, this H is also a vector quantity. The vector's direction is in the direction of external field. Keep this in mind. Its direction is same as the direction of the external field. So H bar is B naught bar by mu naught. Mu naught is a scalar anyways. Okay, so that's something which you are supposed to remember. I give you an example of a solenoid as well. Okay, now don't worry guys, all of this will also come up in the PDF, don't worry. Is a degree till which your magnetic field, external field can magnetize a material. It's called as magnetic intensity. It is B naught by mu naught. Okay, keep this in mind. Okay, it's B naught by mu naught. Shall we go ahead, everybody understanding till here? Nikhil, obviously bits at mock test will happen next week after the JEE mains is over. I have been repeating this again and again. Please watch my previous lectures. I have told this many times. Okay, cool. Great, great. Haishara says thumbs up. Srivatsan says yes, great. Don't worry guys, every student will get benefited, Nikhil. Okay, even if you are 2023, nurture series is starting next week. For 2021, remember, we are already stuck. We are already doing so much for you by conducting all the mock tests and all the live paper discussions. Even the 2022 students need our help. We cannot ignore any of our students. Please understand that. Yeah. Okay, let's get going. Now, intensity of magnetization. Understand the previous one was magnetic intensity. This is intensity of magnetization. Symbol is I. If you ever get confused, remember one thing. Intensity of magnetization. Which is the first alphabet? I. So the symbol is I. That's how you are going to remember it. Here, the first symbol is something else. So the symbol is H. Okay, so that's how you remember the symbols. Intensity of magnetization starts with I. So that's the symbol. Now it is nothing but M by V. Magnetic moment by V. Meaning, you place some material inside solenoid. It got magnetized. Yes, it got magnetized. So, it will have some north pole and south pole. These are basically induced. These are induced due to external field. These are induced due to external field. Whenever you have north and south pole, what will happen guys? There will be a magnetic moment. I have told about this. There is a magnetic moment which is created from south to north. This entire material which is there, it will have some volume. That volume is V guys. So that magnetic moment per unit volume, is called as intensity. That's what it is. I hope this is clear. Yes. So you can rearrange this into slightly different forms, like this is pole strength into length and volume is area into length. LL you can cancel. You can also write it as small m by A. The small m then becomes your pole strength. That's also okay. It's up to you how you want to write it down. And this will become the area. That's fine. It's one and the same thing. Just remember it is magnetic moment per unit volume. That's enough. Okay, of the material which is placed inside some external field. Okay, great. Now, this thing out here, okay, Like I just said, it is magnetic moment per unit volume. There is another formula. There is another formula for that. There is another formula for that. And that another formula, just like you had H was B external, which is B naught by mu naught. H is always related to the external field. I is related to the field which is induced. So instead of H, if you put I, then this B will become B induced by I naught, mu naught, sorry. So that's the way you have to remember it. So H is related for outside field. So H is B external by mu naught. I is related to one which is induced. So it is B induced by mu naught. That's it. As simple as that. I hope this is clear. So you will see that as well in the slide. So induced magnetic field, sorry, intensity of magnetic field is B induced by mu naught. By the way, if you talk about the unit is same as H, because formula for H was also B by mu naught. So obviously the unit should be ampere per meter. I hope this makes sense, because dimensionally speaking it is same as H by mu. Very good, Nikhil. I'm glad you are enjoying whatever subscription. Just do well. Okay, and if you have taken up the subscription, I'm not sure why you are wasting your time here. Please start studying. Okay, please start studying from there. I'm not sure why you are here. All right, so yes, let's get going. Very good. Thank you, Bhaskaran. Shiva, I'm going to start the nurture series from Monday, like I have mentioned. Okay, I don't want to start a lecture and then give you guys a break of 3 days. Again, there will be a discontinuity. So meanwhile, please revise, Shiva, all the previous chapters, all the backlogs, please cover it, because I'm going to start with, you know, a relative motion next week. Okay, cool. Shall we go ahead? Yep. Let's get going to the next one, susceptibility. Okay, now what is susceptibility? See, you take a external field and you take a material. That external field passes through the material. It creates some induced magnetic field. How vulnerable it is, how susceptible it is, how much does it get induced for this much external field. So when you pass some external field, how vulnerable is that material so that it produces that induced field is called as susceptibility. So the ratio of intensity of magnetization, remember I was the term used for how much did it get magnetized. H is the term used for what is the external field, correct? So guys, that ratio tells me how much did it get magnetized per external magnetizing field. That's it. So hence that ratio X which is there, susceptibility, is I by H. This is numerator is nothing but, its numerator is how much it is magnetized. Remember, it's basically dependent on the induced field. Whereas this one, external field, you can see that it was external field by mu naught. So this is output by input. So that is susceptible. If for a given external field, lot of magnetic moment is produced, the X is very good. If for a given H, let's say the value of I is less, that means the induced magnetic moment is less, then the susceptibility is less. I hope this is clear. And since I and H have the same unit, the unit of susceptibility is nothing, because it is dimensionless. Because I and H, remember, both were ampere per meter, gone. I hope this is fine. Yes, Harshita, you are going to get the PDF of the session in the description box as well as the Telegram group. So join the Telegram group so that you will get it ASAP. As soon as the lecture is over, within few hours we update it. Maximum 1 day. Okay? So join the Telegram group. The link is also there in the description box. All right. Aishwarya says thumbs up. I hope everybody is clear about this. Can we go ahead? Yep. Cool, let's get going. Okay, cool. Okay, let's get going, guys, to the next concept. Now the next concept is, probably you can guess from the diagram. The simple diagram should tell you what exactly are we talking about. You are pouring water, there is some rock or some soil, some water is absorbed, some water falls or passes through that particular layer of soil or sand or whatever. How much water is or permeable? What is the permeability? Permeability means how much actually passes through, how much does it permit. So that's the meaning of permeability. That's all. I hope this is clear. Oh, thank you so much, Chinmaya. Good evening, Kushali, join in. So when you take a material and you place it in some external field, what happens is some amount of field might get blocked, because remember, B induced can assist it or can oppose it. So how much is it attracting the field? Is it permitting it or is it not permitting it? So that is permeability. That's all permeability is. And permeability is nothing but is the measure of ease of passage for the formation of field. How easily can magnetic field pass through a given material? If the induced field and external field are in the same direction, if the induced field and the external field are in the same direction, guys, what can you comment? Is the material more permeable or less permeable? Answer in the chat box. Let's see how many of you get this. If the induced field and the external field are in the same direction, is that material more permeable or less permeable? Come on, come on, come on. Yes, Kushali will be taking KVPY sessions, but I would say please join the KVPY crash course, which is going to be conducted from 2nd of August on Vedantu subscription. So please join that. That will be a better way to approach it. It will be more permeable. Think about it, because my external field is there and internal field is also helping it. This was external, this was induced. So this is helping it. So when it helps it, more field lines will pass through it. It will become stronger. Understand, it will become stronger because it is helping it. It's not opposing. If it was opposite, then the permeability would be less. Keep this in mind. All right, very good, excellent day. So here is the thing. The formula for that is B by H. As simple as that. The permeability is B by H. For a given value of H, external field, how much net field is produced? If you are able to produce more field, more permeable. If it is producing less field, then less permeable. As simple as that. Where B is the net magnetic field, okay, and mu is the permeability, and H is the external magnetic field. As simple as that. Okay, I hope this is clear. Very good, my warriors. If you have noted it down, shall we go ahead to the next concept? All these are direct formulas. Now I know you guys are thinking, sir, is permeability somehow related to susceptibility? Because if a material is more permeable, that means it is also more susceptible, vulnerable, it will help it. So probably these two are related to each other, and that's what we are going to see in the next slide. Let's get going to the next one. Okay, so what is exactly the relationship between them? So first of all, let me define a term called as mu r. This is nothing but relative permeability. Okay. Now relative permeability is permeability of medium by permeability of free space. So just to be very, very clear about this, this is for that particular medium or material. This is for free space. Is this something similar to dielectric constant? Remember, dielectric constant was epsilon by epsilon naught. Do you remember this? K, or relative permittivity, was epsilon by epsilon naught, which was dielectric constant. This is very similar to dielectric constant in magnetism. That's it, as simple as that. Panika, you can just put up all your doubts in the chat box, sorry, in the comment box. After the video ends, I don't want to break the flow of the class. All right, cool. Now here is the next thing. Now guys, what we are going to do is, let's start with our basic equation. First of all, net B was B naught plus B induced. This was external field, this was induced field. Let's start from the first. Do I know the formulas for each one of them? Yes. So H is nothing but B naught by mu naught. Cool. So I have B naught here. For B induced, I'll use this formula. I is B induced by mu naught. Cool. And for B net, I will use permeability formula. Permeability formula was nothing but, you know, B by H. Yes. Now it is fine. Now let's start substituting all these values. So B net will be nothing but mu into H. This will be equal, this will be equal to nothing but mu naught into H, and this will be nothing but equal to mu naught into I. All right, now I think it is fine. Now what we'll do is, we'll divide the entire equation by mu naught and H, by mu naught and H, by mu naught and H. Now what will happen? This H and H will get cancelled. I'll get mu by mu naught is equal to 1 plus mu naught goes plus I by H. Now what is mu by mu naught? It's relative permeability. So this will become relative permeability, and this will become 1 plus, what is I by H? That is nothing but X. X is nothing but I divided by H. Yes, X is nothing but I divided by H. So I can just put it as X. So this will become my formula. This is also a formula which you should remember. You should also know the derivation because it involves all the other formulas. It involves all the other formulas. That's the reason for that. Yep. So, can we equate the formulas of permeability and susceptibility? Yes, you can use that. So, I find that this is little bit straightforward. You start from this equation. You exactly start from this equation. That this is just vector addition. Okay, this is just addition of the vectors. That's it. As simple as that. Okay. Everybody fine? Remember this. Relative permeability is 1 plus susceptibility. That's the formula. Cool. It's Dinothor. I have already given all the important topics for all the shifts in a video separately. You can just watch the lecture 180 plus in physics, chemistry, maths. Basically for JEE mains by Shreyas sir. Just search for it and you will get it. Okay. Chalo. Let's start with some questions, guys. Are you ready for some questions? Okay. Let's do this. Come on. Okay. So mu r was mu by mu naught, standard formula, and relative permeability is 1 plus X. Okay. All of this will be there in your, PDF. Okay. Let's see how many of you get this. The magnetic susceptibility of a medium is 0.825. What will be the relative permeability? Come on guys, it's very simple. You should be able to do this. Come on, figure this out. The magnetic susceptibility of a medium is 0.825. Come on, very simple. The susceptibility is given. Sorry, the susceptibility, yes, is given. Yep. And the relative permeability is asked. Which formula will you use? Aishwarya says A, Sai Sadhu says A, Panchami says A, Shivatsan says A. Come on, my warriors. Archana also saying A, Abhinya also saying A, Sai Sadhu saying A for awesome. Yep. So mu r, I just told you, is 1 plus X. So if you know the formulas, it's not that difficult. 0.825 plus 1 is 1.825. That's it. That's the answer, guys. Very cool. I hope you guys got it. Very good. A is the answer. Excellent. These are the kind of questions which are asked. If you don't believe me, check the previous year papers and you will be surprised to know people leave this chapter, and I don't know, I mean, like, people who do this chapter know that this is easy. You just have to study it once and revise it few times just before the exam. You can't have very difficult questions on this chapter. Okay. The magnetic field strength in ampere per meter, that is H, 3 into 10 to the power 3 is given. It produces magnetic field induced of 12 pi Tesla, okay, in an iron rod. Okay. The relative permeability of the iron is question mark. Come on. No problem, Shaktivel. Shaktivel, this is a 12th standard class. This is Pathfinder. This is Pathfinder series. You will see a similar logo, but with different, watermark. Obviously, it will be called as the Nurture series. Nurture is for 11th. Pathfinder is for 12th. Nurture series will resume from Monday because I am very much occupied in the JEE mains discussion of the 12th standard passing out students. Plus, I didn't want to take up too many things and just do half things. So if I do something, I'll do it properly, you know that. Shaktivel, if you're in 9th standard, my God, yeah, you should watch the kinematics of 11th standard for now. Okay, let's see how many of you got this. Which formula are you going to use, guys? Somebody saying 10 to the power 4. Okay, so which formula are you going to use? Permeability, relative has been asked. I think you will need mu is equal to B by H. Mu is equal to B by H. B is given. What is B? It produces an induction of 12 pi Tesla. Okay, so it is producing magnetic field of 12 pi, correct? And H, what is the value of H? 3 into 10 to the power 3, correct? Now the question is relative permeability. Relative will be mu by mu naught. So what is mu? It is 12 pi divided by 3 into 10 to the power 3. And what is the value of mu naught? I hope you remember mu naught by 4 pi was 10 to the power minus 7. So what will be mu naught? It will be 4 pi into 10 to the power minus 7. Now you just have to cancel all these terms, like pi gone. 3 into 4 is 12. 10 to the power 3 and 10 to the power minus 7 will give you 1 upon 10 to the power minus 4. So when you take it on the top, it will become 10 to the power 4. Check this out. Yep, that should be the answer. Beautiful. Okay. Yes, 10 to the power 4, which is option B, correcto. Hello Sushant, join in. Okay, let's get going to the next question, guys. So you can see the questions are very straightforward. Yes, have I done the second and the first session of physics class 12? I'm not sure which second and first session you're talking about, Vicky. If you can mention the chapter name, probably I can tell you. It's all there in the playlist, Vicky. I hope you know how to search playlist, how to search videos. I'm pretty sure you are well aware of that. Just search for it, you will get it. All the chapters are there. Just search for it. Okay. So, next question. Just watch the replay, Arun Kumar, you will get it. See, permeability relative was asked. Relative permeability is mu by mu naught. So, you need to find mu. Is there a formula for mu, B and H? Yes, mu is B by H. Use that, you will get it. Okay, come on, let's get going. Intensity of magnetization for a magnet whose magnetic moment is given and dimensions are also given is how much? Very straightforward, direct. Electric charges, Vicky, is already done, bacha. It's already done. Check it out. It's there in the playlist of electrostatics. It was the first session. And by the way, Vicky, the same flow might not be followed. So don't think you have joined some coaching and there is session 1 of charges, session 2 of something else. Maybe the flow might not be same. Obviously, each teacher has their own unique style of teaching. Hello, Chirayu. Welcome aboard. Join in. Yes, Aishwarya, that's the formula you need to use. I just gave you the formula. Intensity of magnetization. Look at the first alphabet, I. So, I is magnetic moment by volume. What is the magnetic moment? It is 2. What is the volume? 10 into 2 into 1. But these are all in centimeters. So convert it into meter cube. Yeah, as simple as that. So what are you going to get? 2 cancels. So you're going to get 1 upon 10 to the power minus 5. So you take the minus 5 on the top, it will become 10 to the power 5. So that should be option D. That should be option D. I hope this makes sense. Geeta have completed kinematics of 2D. Please watch the playlist, bacha. It's all there. I mean, you just have to check the playlist. So the correct answer is D. So if you go down below, okay, if you go to our channel, Enthuse, out here, okay, so you will see playlists out here. Yeah, check out the playlist. Okay, and what you need to do, just go to physics. Everything is there. I mean, you just have to search. A lot of people don't search. I don't know why you guys don't search. Geeta, that's what I'm saying, bacha. Is there? Check this out. What am I teaching? Check this out. Units and dimensions done. Vectors done. 1D done. 2D motion done. For 12th standard, electrostatics done. Gauss law done. Current electricity done. Capacitors done. Magnetic sources and effects done. Magnetism going on. You might be wondering, sir, what is this now again? These were the previous lectures conducted last year. So it's also there. If you want some next chapter, Newton's laws, work, power, energy, but these are very condensed lectures. These are flash series. But if you want, you can watch. These are little bit condensed. The ones here, Pathfinder and Nurture, they are little bit more elaborate, and this is a proper long-term series. Vicky man, what do you mean by shall I complete syllabus? Obviously, bacha. Okay. Let's get going to the next one. Obviously. Okay. Now it's story time. Ready to hear a story? I hope this is clear. Thank you, Chirayu. Okay. Well, first of all, smash the like button, then I will start the story. Yo. Nice. Panchami says yes. Shivatsan says yes. Chandra, yes, you are quite late. Every day my lectures start at 7:30 on this channel. So if you are regular, you know my timing is 7:30. Don't be late. Okay, cool. Now it's very simple story. Some of you might have heard this story, but it's okay. No problem. Now in order, see, first part of the chapter is done, by the way, and we are now moving to the different types of materials that you can produce in magnetism. Now, first thing that you should have in your mind is that any rotating body which is charged, any revolving, rotating body which is charged is nothing but a magnet. Yeah, just get it in your head, and I have given you a formula for that. How many of you remember that formula? M by L is Q by 2M. M by L, magnetic moment, by angular momentum, is charged by 2M. So if you have a sphere which is rotating, think about it. It has angular momentum, it also has a magnetic moment. It also has north and south pole. How do you get north and south pole? Use right hand rule. If it is rotating like this, thumb will point in the north. If it is rotating like that, thumb will point in the north, like that. As simple as that. Very good. Now, here is the thing. Any bar magnet, any horseshoe magnet that you see, it is made up of atoms. And what are atoms made of? Electrons and protons. And what are electrons? They are charges. And what do electrons do? They revolve. They revolve around the nucleus. So aren't they, actually speaking, teeny weeny magnets? Think about it. Anything around you, wood, your hand, your watch, your computer screen, your wall, anything is made of atoms. Atoms is made of charges. Charges are rotating. Rotating charges are nothing but magnets. Just get it in your head. Alright. Now, you might be wondering, sir, if everything is magnetic around us, then why don't I get pulled by this chair or this wall or something else? Now, the reason is something different. Let's see. So, for that, let's bring in Pandu. Here is the thing. Let's imagine, like I was telling you a story, right? So imagine a class full of students, boys and girls or whatever, anything, and each student is like a charge who has his own magnetic properties. The direction in which the student looks, okay, the direction in which the student looks is the direction of the north and south pole. So it's the direction in which you can visualize a magnet. So if I'm a student, I'm looking here, it's like I'm a magnet, my north pole is there, south pole is behind. Another student looking here, the north pole is here, south pole is here. There is a magnetic moment. Each student is nothing but a charge, electron, which is rotating. There is a bench. Each bench is like an atom. Each bench is like an atom. And on a bench, you will have multiple students, correct? So just like in an atom, there are multiple charges, electrons which are moving. On a bench, there will be multiple students. So who is sitting beside Pandu? Everybody knows this. Champa is sitting. Obviously, Champa loves Pandu, Pandu loves Champa. And Pandu is looking, I don't know, somewhere here. So that's his magnetic moment. Champa, I don't know, she might be looking somewhere else. So she will also have her magnetic moment. So on a bench, which is nothing but an atom, there could be multiple students. The students are analogous or similar to electrons. Each electron or each student will be looking in different directions. That means they will have their own magnetic moments. Everybody clear till this point? Yes, Panchami, there is a magnetic field around the earth. Yep, correct. Everybody fine till this point? Cool. Now, in a classroom, there will be many benches. There will be many benches. That means many atoms will be there because each bench is an atom. And what is that classroom telling? A classroom is similar to a material. Anything, any object. An object is made of many atoms. So classroom has many benches. The benches have many students. Each student is like an electron. As simple as that. Is that clear? Everybody fine? Everybody is able to visualize this? Each student looking in different directions. That's the direction of the magnetic moment. As simple as that. Now, here comes the next point. Okay, cool. Very good. Everybody understanding? Please put up a yo if you guys have understood till here. Now, imagine a bench that is an atom. A student like Pandu might be looking somewhere. Okay, he's looking somewhere. He's producing his magnetic moment. His neighbor on the bench, which is Champa, might be looking somewhere else. I don't know. And these two magnetic moments might add or produce a resultant vector like this. So the bench has a magnetic moment. Matlab, that atom has a magnetic moment. Pandu looking here, Champa looking here, the resultant is here. So, and an atom, one electron producing magnetic moment here, another producing here, resultant is here. So the atom has a resultant magnetic moment. As simple as that. Now, the next thing is, this is one possibility. Second possibility, Pandu and Champa fought. Here they both are very happy, but maybe they fought. So Pandu is looking one side, Champa is looking the other way. In that case, both their magnetic moments will cancel each other. There will be zero net moment. Everybody understanding till this point? Yeah, there could be zero. There will be zero magnetic moment. They are fighting with each other. One here, one there. Zero resultant. So a bench might have net magnetic moment or zero magnetic moment. That means PL, concentrate on the class. Let's focus on the class right now. Yeah. So that means whenever you have an atom, it could have a net magnetic moment or it could have zero magnetic moment as such. That zero will happen because the electrons' magnetic moment cancel each other. And if there is a magnetic moment, that means the electron's magnetic moment somehow produce some resultant unbalance. Tulsi, there is a crash course starting for KVPY. It's for 4,000 rupees. The link is there in the description box. Join it right now for your KVPY preparation. It's there. Yes, the KVPY series will start on 2nd of August. Okay. Now, when you have many benches out there, what will happen, guys? Think about it. Each atom will have their own magnetic moment, maybe like this, like this, like this. And maybe the benches are not aligned in the same way, or maybe the students are looking in different ways. So each atom will have different directions of magnetic moments. This is your classroom, this is your bench. Pandu Champa, Pandu Champa, Pandu Champa, Pandu Champa, Pandu Champa. Each one of them producing resultant magnetic moment somewhere else. Now, if I ask you what is the total magnetic moment of this material, what will you do, guys? If I ask you the total magnetic moment of this material, what will you do? This magnetic moment plus this magnetic moment plus this magnetic moment plus this plus this plus this plus this plus this. Vector addition. Vector addition. That means the net may be zero or may not be zero. Guys, if all the non-magnetic atoms have no magnetic moment or they cancel each other by random orientations, then the net magnetic moment will be zero. They could be cancelling out each other, but maybe they don't cancel, and if they do not cancel, then it will be magnetic. Understand that. Yes, it will be the sum of all. The sum could be 0. The sum could be 0. Okay, it will be non-magnetic if they cancel each other, else it will be magnetic if they produce a net unbalance. It depends, completely depends. Yes, it's like a free period. Okay, randomly some students are talking to that student, hey, how are you, man, what did you do this weekend? This student is talking to, hey man, how are you, let's go play football, hey, did you play PUBG? So it's all random. And sometimes maybe somebody is passing by, or I don't know, some students are serious, or everybody is sleeping in the class, so they are all oriented in one particular direction, so all their magnetic moments might add and produce a net magnetic moment. I hope this is clear. Cool? Yes. So till now what has happened? Each atom is made of electrons. Each electron has its own magnetic moment. Each electron's magnetic moment might add to give a magnet, or they might cancel and it might not have a magnetic moment. Now each atom's magnetic moment together might add or might cancel. So the material might be magnetic or non-magnetic based on this. I hope this makes sense. So for example, if I take this pen, is this pen magnetic? Is this pen magnetic? Think about it. Visualize this. Hello Paparazzo, welcome aboard. Welcome Ritesh. I hope Guru you have understood this now. Yeah. So is this pen magnetic? Is this remote magnetic? Am I magnetic? No, right? So what is happening? The atoms inside this are having magnetic moment maybe, but they are cancelling each other. They are cancelling each other. That's all. Or maybe the atoms themselves don't have magnetic moment. As simple as that. Okay. So that's what it is. Great, great. Hello Daksh, long time no see. Yes, I hope you are doing well, and I really hope that you crack JEE this time, bacha. All the best. Okay, now imagine all these atoms having their own magnetic moment. This is one bench, second bench, third bench, fourth bench, fifth bench. Atom, 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 electron, 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 electron are sitting there having a gala time. And now comes, so these are all the materials. These are all the atoms of that material. Now comes an external agent. Who is that external agent? Let's say a teacher. Okay, one teacher comes inside. Yeah. So now things change. Now things change. All these Pandus and Champas are sitting probably. The moment that external teacher comes, Guru comes, things are going to change. And that creates 3 different types of materials. What does it create, guys? It creates 3 different types of materials based on how these react to an external agent. There are 3 possibilities. There are 3 possibilities to how Pandu and Champa react. And let's see all the 3 possibilities. First possibility. Everybody ready? Yes, Bharat, even your NEET student can watch these lectures. First reaction that is possible. A teacher comes inside. These are all the benches. They are all loving each other. Pandu is looking at Champa. Champa is looking at Pandu. They are lost in love. Okay. So when they are lost in love, what will happen, guys? Magnetic moment of Pandu, magnetic moment of Champa will cancel. Each atom has 0, 0, 0, 0, 0 magnetic moment. Correct? Everybody fine? Each atom has 0, 0, 0, 0 magnetic moment. No atom itself has magnetic moment. Correct, guys? Very good. Now the teacher comes. The teacher comes. The moment the teacher comes, what happens is Champa hits Pandu. Hey Pandu, look man, teacher has come. So Champa looks towards the teacher. Pandu is like, no, what the hell? Why did the teacher come? I'm going to look behind. So the moment Champa turns towards the teacher, Pandu looks behind. But Champa is not so, I don't know. She's very teeny meeny, let's say. You saw Pandu is a little bit big, right? That minion. Champa's magnetic moment is less. Pandu's magnetic moment is more. Pandu is looking behind. Champa is looking towards the teacher. Net magnetic moment is against the teacher. net magnetic moment is against the teacher. So the moment external magnetic field came, each atom developed. When an external field is created, everybody is asking, hey, look here, the teacher is there. An external field is created, the net magnetic moment is opposite. You can see north is below, south is up. North is below, south is up. You will see that a magnetic field is created opposite. These are very badmash bachchas. These are very nalayak bachchas, kamina bachchas. They are looking against the teacher. Teacher is there, students are looking here. Interesting, right? Champa is hitting Pandu's head. Pandu is like, no, I'm going to look behind. Pandu's magnetic moment is opposite. Champa is looking here. She is not so powerful because she's teeny mini. So that's what net magnetic moment is behind. So that's what happens. So do you see induced magnetic field is opposite to the external field? Everybody clear till this point? Now let's say the teacher gets angry and the teacher walks away. External field is removed. External field is removed. What will happen? Back, love story is back. Again, they will. The moment you remove it, you will say they'll be back to normal. They'll start looking into each other's eyes, lost in love. They will come back to their original state. They will again become non-magnetic. As simple as that. Yeah. Is that clear? So this kind of material which opposes the external field temporarily. Why temporarily? Because the moment external field goes away, the induced field also disappears. It will come back to its original non-magnetic nature. That's what will happen. That is called as a diamagnetic material. Look at this diagram. Everything is mentioned here. External field is here, induced field is opposite. External field is here, induced field is opposite. That's it. We show you will have micro courses for KVPI and YouTube also will have KVPY, but you should rely more on the crash course, not on YouTube. Let me tell you that. Okay, cool. So this is called as a diamagnetic material. Examples of these are water, hydrogen, NaCls, that's salt, silver, mercury and diamond. All these are diamagnetic materials. There is a very good chance, Manoj Kumar, and they are repelled by external fields. You can see they are produced opposite, they are opposing, so they are going to be repelled. If you have an external field, they are going to be always repelled by external fields. Third important point, the atoms do not have magnetic moment. You saw that earlier the atoms did not have. Only when external field came, they produced magnetic field, which is temporary in nature. This effect is temporary, so keep that in mind. The moment the external field goes, that's it, the atoms will lose their magnetic moment. I hope this is clear. Very good. Now, next, this induced field is much lesser than the external field. So it's very small, guys. Don't expect it to be very large. It's very small. And the susceptibility is negative. Why is the susceptibility negative? Try to think about it. Susceptibility, remember, X was IH. So if external field is in this way, induced field will be in the opposite way. So if you see numerator and denominator sign wise will be opposite, hence X is negative. If external field is this way, induced field is opposite sign, hence negative. I hope this is clear. Very good. Next up, this value is independent of temperature. It's not going to be affected. Sometimes the material's properties get affected by temperature, like you will see, but for this it will not be affected. Keep this in mind. And the relative permeability will be less than 1. This is also very easy to see. Why this will happen? Because I just told you mu r is equal to 1 plus x. This is a small negative number. If it is a small negative number, 1 plus a negative number, imagine 1 plus minus 0.1, what will you get? You will get it as 0.9, right? So it is less than 1. Keep this in mind. That's how it works. Paparazzo says clearo, very good, excellente. So that's what you should know, guys. Very important. Great. Next up, all this will come in the PDF. The B versus H graph for a diamagnetic material. Okay. So, Divya, you're going to get blocked, man. Okay. Okay, cool. So I think Divya is blocked. Alright. So, B versus H curve. How will the B versus H curve look like? This is, remember, external field. This is the field which is created because of that external field. So what will happen? The moment you increase H, B will also increase, but in the opposite way. So that's what will happen. Look at this. This is negative. This is positive. Why is this graph coming here? When you make H positive, B will be created in the opposite direction. That's why it is negative. And when you remove it, it will go back to 0. That's all. As simple as that. Everybody fine till this point? So when you create external field, it will be there. When you remove that, it will come back to 0. As simple as that. I hope this is fine. Shall we go ahead? Yep, clear? Okay, cool. Let's see the next variation. Let's continue the story then. Okay. Now, second story, second type of behavior. Second type of behavior. First was diamagnetic. It was very badmash kind of bacha. When the teacher came, the students were looking opposite. Now, in this type of behavior, each atom has magnetic moment. Yes, there are magnetic moments. So, maybe Pandu and Champa looking here, another Pandu and Champa looking at the window, another Pandu and Champa looking at the back, another Pandu and Champa, I don't know, maybe looking at the board. So, each atom has magnetic moment, but they are randomly arranged. So, this randomness will totally add up to give you a big fat 0. As such, the net magnetic moment is 0. Everything is random. And this is going to be paramagnetic, yes. Now what happens? The moment a teacher enters inside, one Pandu Champa, they decided they are looking here, another Pandu Champa are looking here, another Pandu Champa are looking here. The moment teacher comes, all the Pandu Champas are like, hey, come on man, teacher came, let's look at the teacher. So they all look at the teacher. So all these atoms reorient themselves when an external field comes. See how they got rearranged? So before, they were all random, external field came and you saw that they got reoriented. That's it. So they got reoriented. So they will be paramagnetic in nature. That means they help the external field. Now what happens when the teacher goes out? That means the external field goes out. The moment the teacher goes out, so if it is removed, external field is gone. These atoms come back to their original state. Again back to random. So this is temporary phenomena. It's not permanent, it's for temporary. So whenever external field is there, they will arrange themselves in that orientation. When the teacher goes away, external field goes away. Back to randomness. This is a temporary magnet, as simple as that, nothing else. Great. So for a paramagnetic material, examples are aluminum, manganese, magnesium, sodium, potassium, oxygen. This effect is temporary. So as long as the external field is there, it will stay. Atoms themselves have non-zero magnetic moment, which are randomly oriented. They will realign in the presence of external field. Remember that. This induced field is also very less. It's not very large. It's very, very small. And it is in the same direction like I told you. And the susceptibility is also very small. Why is the susceptibility very small? Again, I can explain you that. X is I by H. If H is here, I is also here, but H is very large. I mean, even if H is very large, I is very small. Not much of magnetic moment. This is very small, guys. So not much of induced field. So that's why X is very small. And this is very important. It's inversely proportional to temperature. Very, very important questions can come. This is called as Curie's law. This is called as Curie's law. Okay, very, very important. X is equal to a constant by T. That constant is called as Curie's constant, and this law is called as Curie's law. Keep this in mind. X is Curie's constant by temperature. More the temperature, susceptibility will reduce. Less the temperature, susceptibility will increase. Very important. Okay, cool. And the last point, because mu relative is 1 plus X and X is a number which is positive, mu r is more than 1 plus X. I hope that's clear. Shall we go to the third type? Everybody fine till this point? Hello Aditya, welcome aboard. Shall we go ahead? Let me know guys in the chat box. Last type of material, but before that, yeah, the BH curve. Yep, BH curve. How will it look like? When you increase the external field, then the magnetic field will increase in the same direction. Look at this. This is positive. This is also positive. It's not opposing. It's assisting. That's why it's in the first quadrant. For diamagnetic, it was in the fourth quadrant, because when you increase this, B was opposite. That's why it's here. And when you remove it, it will come back to 0. That's why this double arrow mark. As simple as that. Excellent. Okay, so this graph is also important. This is for paramagnetic material. Okay. This is Curie's law, which I was talking about. When you increase temperature, the susceptibility will reduce. That is called as the Curie's constant. You should know that. Okay, cool. It's all there in the chat box. I mean, the PDF. Great. Now the third type. And the third type of behavior is where there are different houses. I'm pretty sure your school, college, whatever had houses, green house, yellow house, violet house, whatever. So there is a groupism formed between the students. And a group is called as a domain. And what happens in group is that a group will collectively decide to look here. Maybe the yellow house decided we are all going to look there. Fine. All the students are going to look there. That means all the atoms in a group, which is a domain, will be oriented in a particular fashion and they will produce a net magnetic moment. Yes, Roshan, it will be enough. Yes, a group has a net magnetic moment. Now, why that happens, the theory for that is very complex and it's not a part of JEE, but you remember this word, it happens because of exchange coupling. That's all. That's all you need to remember. Okay, just remember it happens because of exchange coupling. What is exchange coupling? You don't need to know. It's not a part of JEE. Now there will be many groups. Yellow house, blue house, green house, violet house, red house, orange house. I don't know. So each house will have a particular orientation, direction. They will look here, they will look here, they will look here. They will be all randomly oriented. These are all the groups. I hope this is fine. What will happen? The effective magnetic moment, guys. What will happen to the effective magnetic moment of all these groups? Come on, quickly answer in the chat box. If I add all these magnetic moments, what should I get? Quickly answer in the chat box. Very good. 0. This, random. It's all randomly oriented. Correct. They will cancel out each other. As simple as that. Correct. Now, if they are going to produce 0 magnetic field as a total, net magnetic field is 0. Great. What happens when some teacher comes? Okay. That is, oh, by the way, this is how it looks like in a material. These are small domains. Each domain has an orientation. They are randomly oriented. That's why net magnetic field is 0. Now the moment and teacher comes, things change, guys. What happens is, the moment external field comes, that group which is looking towards the teacher, they will grow in size. They will kidnap, hijack the members of the other gang and they will grow in size. Let's say orange house was looking towards the teacher. Orange house will be like, hey, come on man, yellow. Come to our group, we are looking towards the teacher. They'll slap and they'll increase the gang size from 0 to hero. So the size of the domain will increase. Look at that. This gang was looking towards the teacher, so that will increase. The other sizes will decrease. That's what will happen. So normally they will not have net magnetic field. The moment somebody comes, the gang will grow. It will grow. It will grow. But there is a catch. Let's say the teacher leaves, okay? We'll see what happens. So you can see most of the domains will arrange themselves towards the teacher. Now the moment the teacher leaves, the best part is, once a bond is formed, bro code, you cannot break that code. This gang is formed. This gang will not go away. It will stay there. It's not like because they hijacked from yellow, the yellow guy is not going to be like, okay, please let me go. A teacher is gone. Can I go back? No. There is no relaxation. Once you are a part of the gang, you are a part of the gang. The size has grown. That's it. No change in the orientation. It stays there. So now, is it a temporary phenomena? Obviously not. The external field has gone, and you see the magnetic domains are still oriented the way it is. So that's a permanent magnet. So that's what happens in a permanent magnet. As simple as that. Okay. So domains before the magnetization are randomly oriented. At the moment you place some external field, it's magnetized in a particular direction. The domains grow in sizes. Examples: ferrous, nickel, cobalt. All these are good examples of ferromagnetic material. This effect is permanent, it's not temporary. So you use this for making permanent magnets. The atoms themselves have permanent dipole moment, obviously, and the induced field is much larger than the external field. Yeah, this is the beauty of ferromagnetic material. You apply some field, the domains orient themselves, make themselves stronger, and they assist the external field. That's why X is very large. Susceptibility is very large. And this is the most important law. X is proportional to 1 by T minus Tc. Why is it 1 by T minus Tc? This is called as the Curie temperature. What is the Curie temperature? At T more than Tc, ferro will become para. When you increase the temperature, atoms start vibrating, they start shaking, they start moving, lot of kinetic energy. That's it, they will break the bonds, they will be like, enough of groupism. They will all break their bonds and they will become individual atoms, separate, not related to each other, and they will turn into paramagnetic. That's why they will obey this law. So, only after critical temperature, inversely proportional to the temperature changes. That's why it will become paramagnetic. Remember this. Okay. And relative permeability is very large. As simple as that. Hello everyone, join in. Okay. And how will the BH curve look like? Okay. How will the BH curve look like? It's very simple. It's non-linear. When you increase H, external field, the B will also increase. Okay. It will increase. But if you remove the external field, that means you make H as 0, you will see it will hardly, no, it's not going to come back to 0. Remember, it will maintain it. So it will retain the magnetic field. That's why this is called as retentivity. Retentivity means how much has it retained when external field has become 0. So at this point, what has happened, guys? External H is 0, but B is not 0. It has retained it. That's why this graph is backwards like this. I hope this is clear. Correct. Now you change your mind. You had the teacher in the front. All the groups looked forward. All the groups oriented forward. The teacher left. Still the groups are looking in the front. Now the teacher comes from behind. Now the groups are like, oh my God, what the hell? So some groups start turning backwards. Some groups are like confused. There will be a point when you create negative field from outside and make the magnetic field 0. Look at this. What is the speciality about this point? B is 0. H is reversed. You can see H is reversed. So you have removed, you have coerced. Coerced means forcefully. You have forcefully changed the orientation of the class and nullified. Everything has been destroyed. The magnet has been destroyed. You can see there is no more magnetic property left. It has been coerced. You have forced. Coerce means force in English. Okay. So you have coerced it into losing its magnetic property. So this is called as coercivity. Okay. So remember this. How much field you need in the opposite reverse direction to make sure the magnet is destroyed. That's coercivity. As simple as that. Yep. And yeah, you can continue this curve. Now, since the path while going and while coming is not the same, going and coming, it's not the same. That's why there is some area inside it, and it is called as hysteresis. This is called as hysteresis loop because the going path and coming path is not the same. As simple as that. And this area represents energy per unit volume which is consumed, joules per meter cube. So for example, this much area is the energy required for magnetizing. Energy required for magnetizing it from here to here. So you can see this much area will be the energy, required while demagnetizing it. This is the loss. This much will be the loss. As simple as that. Okay, so the difference of that area will give you that loss. Understand? Okay, so that's how things are. Keep this in mind. Okay, so that is why it is called as hysteresis. Aditya, start watching from little bit before in case you did not understand. What is chi? Not sure what is KHI. What is KHI? I'm not sure what you're talking. Please, probably you can ask me later on again in the comment section. Sanjana, for me, at least to complete physics portion, I'm going to take hardly 2 months for 12th standard. JEE 2022, 2 months. I'm done. Okay, how about this quickly? 3 questions for you guys, 3-4 questions, come on, quickly. Which is the most suitable material for making permanent magnet? The answer is, remember, steel. Steel is the, no, it's not D, it's steel. Steel is the best material to make, permanent magnet. Keep this in mind, okay? Next, magnetic lines of force prefer to pass through ferromagnetic materials because of their magnetic lines prefer to pass through ferromagnetic materials because of their what property? What is there? What is more? What is less? Relative permeability is more, susceptibility is more, and yes, permeability is high. Yes, so correct. Both are high. Answer is C. Correct, Aditya? Both are high. Yes, Madhu, you are very late. Almost at the end of the class you are. Permeability is high. Susceptibility is high. That's why they will prefer to pass through ferromagnetic material. Keep this in mind. Next, a permanent magnet, the permanent magnetic moment of atoms or molecules of a diamagnetic material is, koi baat nahi Bhanwar. The permanent magnetic moment of dia, try to recollect dia. Dia was where Pandu and Champa were looking at each other. They were lost in love. So each bench had 0 magnetic moment. Remember, yes Aditya, correct. The answer is 0. So remember, Pandu and Champa lost in love. So 0 magnetic moment. The moment teacher comes, Champa looks forward, Pandu looks behind. Net magnetic moment opposite. When teacher goes back, 0, 0, 0, 0 back. Okay. So needle 1 is ferro. Needle 2 is para. Needle 3 is dia. Then when a magnet is brought close to them, which one will it attract weakly or strongly or repel? Think about it. You guys should know this now. Come on. Yes. Come on, my warriors. N1 is ferro. N2 is para. N3 is dia. Then when a magnet is brought close to them, what will happen? Think about it. Ferro, strong magnetic properties, permanent, it will help. So won't it attract strongly? Para, it will attract, but it is not so strong as a ferro. It will help. It will be oriented in the external field. But dia, that will repel. Remember, it always repels. It's opposite to the external field. So it will repel weakly. Hence the answer is C. Correct. These are the kind of questions which will be asked in JEE mains. By the way, I have kept 2 questions as homework for all of you. This is the first question. Post your answer in the comment section below. Check that out. Okay. So Arun, please watch the lecture from the start in case you missed it. Ferro was very strong. Remember, ferro was very strong, magnetized in the direction of external field. That's why it will attract. Para is also magnetized little bit, but not as strong as ferro. So it is weakly attracted. But N3, which is diamagnetic, it will always repel it. Keep this in mind. It's opposite to the external field. So the first question and for homework, and this is the second question, okay, for homework. Okay, what are the quantities for diamagnetic material? Okay, for permeability and all of that. All right. Now, let me tell you two important things. One is, if you go to our video right now, let's say you go to our video, there are two important things. A lot of you are asking, sir, when is the KVPY batch starting for SX? So you can see, get KVPY SX crash course for 4,000 rupees. There is a link. Now this crash course has 20 lectures of physics, 20 lectures. I'll just write it down in case you forget it. Okay, 20 physics, 20 chemistry, 20 maths lectures, along with tests and discussions. Okay, and not just that, guys, there are also PYQ problems which are discussed of, this is for SX. So SX means it will be both 11th and 12th standard. So that is for 4,000 rupees. If you have some money in your balance, so you can use that as well. Now, this is my demo account. And by the way, this course will start on 2nd August. That's this Monday. And the entire KVPY, portion, whatever is required, will be revised, all right, for physics, chemistry and maths via 20 lectures. Now look at this. There is a coupon code which you need to use. If you do not have the coupon code, then probably you'll have to shell out a little bit more. So SHKVPY, that's the coupon code which you need to apply. And when you apply it, you get that discount, or else you'll have to shell out some extra money. Second important link that you need to check is basically the Vedantu Pro subscription for the 12th standard students. And this is a long-term batch. Now the best part is, if you are in the long-term batch, KVPY course is automatically available for you guys for free. Yes, it's for free. You don't have to shell out 4,000 rupees. Arun, I live in Bangalore. Yeah. So this is for free. And this course, total price is 35,999 till the next year, JEE Advanced. It includes doubt solving during the class, assignments, test series, analysis, online classes, recordings, PDFs, and all the courses which happen during the long-term batches, apart from the regular JEE classes like KVPY, Olympiad. All these courses, my micro courses, also for free. If you are a part of the Pro, there is 3 versions. So the classic version basically is where you have doubt solving also. So check it out. The coupon code is SHHPRO. I think it's time also for Shimon sir to join in. So guys, check this out, and I hope you guys had a great time tonight. And do join the Pro subscription, because KVPY course will then be for free. But if you just want KVPY, then you can check the link below. All right. Take care, guys. Hasta la vista. This was Shreyas here. See you tomorrow for the Menti quiz at 7:30 sharp. Bye bye.